Nikolai Vavilov was born in Moscow in 1887 into a merchant family, the older brother of physicist Sergei Vavilov, with an upbringing shaped by orthodox discipline, though he became an atheist. His father had endured poverty from crop failures and food shortages, an experience that deeply influenced Vavilov's lifelong mission to end famine through science. In 1906, Vavilov entered the Petrovskaya Agricultural Academy, where he became known for carrying a pet lizard in his pocket as he studied agricultural pests. He graduated in 1910 after writing a dissertation on snails as agricultural pests, beginning a career focused on improving crop resilience and yield. From 1911 to 1912, he worked at the Bureau for Applied Botany and the Bureau of Mycology and Phytopathology, studying plant diseases and fungal infections. Between 1913 and 1914, Vavilov traveled across Europe, collaborating with British biologist William Bateson, who helped establish the foundations of genetics. In 1916, Vavilov led his first expedition to Iran, collecting 171 new legume seed samples including beans, chickpeas, lentils, and peas. These samples suggested a center of origin for cultivated plants in Southwest Asia, forming the basis of his emerging theory on plant domestication. In 1917, he became a professor at the University of Saratov's Faculty of Agronomy, teaching agricultural science and plant breeding. By 1920, Vavilov was appointed director of the Bureau of Applied Botany in Leningrad, expanding his research on crop diversity. He organized expeditions to Central Asia, Afghanistan, Japan, and Taiwan, gathering seeds and studying local farming practices. In 1921, he visited North America and concluded it was not a center of plant diversity, later identifying centers in Mexico and South America. On his return, he collected seeds across Western Europe, including Britain, France, Holland, Germany, Poland, and Sweden in 1922. From 1924 to 1935, he directed the Lenin All-Union Academy of Agricultural Sciences in Leningrad, building a vast seed collection. He traveled the Mediterranean in 1926, visiting Greece, Spain, Portugal, North Africa, and islands like Sardinia and Cyprus. He studied legumes like chickpeas, noting their role in soil fertility and their importance in regional diets across southern Europe. Another expedition took him to Jordan, Palestine, and Syria, where he collected seeds of white lupin that matured early. Later, he traveled to Sudan and Ethiopia, identifying a major center of crop diversity in 1926. In 1927, Vavilov presented his theory of centers of origin at the 5th International Congress of Genetics in Berlin. By 1933, his institute in Leningrad held over 148,000 seed specimens, the largest such collection in the world. The collection gained international acclaim but drew hostility from Joseph Stalin, who distrusted scientific independence. In 1929, he traveled to China, Japan, and Korea, identifying another center of cultivated plant diversity in East Asia. In 1932, he made his final expedition, visiting Cuba, Mexico, Ecuador, Peru, Bolivia, Chile, Brazil, Argentina, and Uruguay. That year, he proposed hosting the 7th International Congress of Genetics in the USSR in 1937. In 1935, he was elected chairman of the International Congress of Genetics, tasked with organizing the event. But in 1936, the Politburo canceled the Congress, banning Vavilov from traveling abroad. At the 1939 Congress in Edinburgh, an empty chair symbolized Vavilov's forced absence. Trofim Lysenko joined Vavilov's Institute and opposed Mendelian genetics, promoting Lamarckian ideas of inherited traits. Lysenko claimed crops could be improved through vernalization and rejected the concept of genes as bourgeois pseudoscience. Stalin favored Lysenko's ideas, summoning Vavilov to the Kremlin where he mocked his scientific methods. In 1936, Lysenko arranged for Vavilov to be removed from his position as head of the institute. While collecting seeds in Ukraine in August 1940, Vavilov was arrested by the NKVD on charges of espionage. He was accused of sabotaging Soviet agriculture and working as a British spy, charges based on political vendetta. After repeated interrogations, Vavilov signed a false confession under duress, a common practice in Stalin's purges. In July 1941, he was sentenced to death for his opposition to Lysenko's pseudoscientific doctrines. His sentence was commuted in 1942 to 20 years in prison, but the conditions remained brutal. Vavilov died in prison in Saratov on 26 January 1943, weakened by malnutrition and disease. Medical records noted pneumonia, dystrophy, and edema, but the death certificate cited only cardiac decline. Some historians believe the true cause of death was starvation, a result of systemic neglect. Vavilov's first marriage to Yekaterina Sakharova produced a son, Oleg, in 1918, but ended in divorce in 1926. He later married Elena Ivanovna Barolina, a geneticist and lentil specialist who worked at his institute. Their son Yuri was born in 1928, growing up surrounded by plant research and scientific inquiry. Vavilov became the youngest member of the Soviet Academy of Sciences, earning the Lenin Prize in 1928. He served as president of the All-Union Geographical Society in 1931 and was elected a Fellow of the Royal Society. In 1955, a military court voided his death sentence during Khrushchev's de-Stalinization campaign. By the late 1950s, Vavilov's reputation was restored, and he was honored as a hero of Soviet science. Vavilov foresaw that plant varieties would vanish without deliberate preservation, pioneering the concept of seed banks. The Leningrad seed bank housed over 120 tons of seeds, roots, and fruits, including 6,000 potato varieties. When German forces besieged Leningrad in 1941, evacuation orders spared art, but not the seed collection. Scientists at the Vavilov Institute moved a selection of seeds to the basement and began guarding them in shifts. They protected the collection from fire, cold, rodents, and their own hunger during the 8 tens and 2-day siege. They refused to eat the seeds, even as starvation claimed their lives, one by one. At least 19 researchers died, most from starvation, having chosen to preserve the collection. In 1943, German forces seized parts of Vavilov's collection in Ukraine and Crimea under Heinz Bruscher. Many samples were transferred to the SS Institute for Plant Genetics at Schloss Lahnach in Austria. The Institute's legume collection supplied germplasm for over 3/4 of Soviet legume varieties bred after 1940,